All right. Hello. This is the first of the videos that I'm gonna create with regards to my absence. I apologize again. But last meeting we discussed the concept of a one-sided limit and all of the limits uh it pertains. Now remember that a limit exists if both the left hand and the right hand limits coincide. Now we're gonna look at uh problems that look like this. Suppose that our function right here, f of x, is equal to 1 over x minus 1. What if we will ask, what is the limit of this function right here, 1 over x minus 1, as x approaches 1, right? Now, the natural thing here is you would try to substitute, but there's something wrong. If you try to substitute 1 in here, well, you get 1 over 0. So if you can't go anywhere if you just substitute. Okay. Now, again, like before, we cannot directly substitute in here, unlike before. And we need to be careful. We first need to find the left-hand limit, which is the limit of 1 over x minus 1 as x approaches 1 from the left. Okay. And the right-hand limit, which is the limit as x approaches 1 from the right. Now, in here we are still stumped because you can try to substitute, but nothing will still happen. So what is the recourse here? Well, let's try to have a table of values. Let's try to have all x's here and all f of x here. Okay. Now, what we're gonna do is we're gonna substitute numbers. Okay. We are substituting numbers that are close to 1. Remember, it's important that they're close to 1, but to the left of 1. Remember, because it's 1 from the left. So in this particular case, what we're substituting are numbers like 0.9, right? And we go closer and closer to 1. So let's just add multiple 9s, 0.99, 0.999, etc. Let's add one more. Okay. And what do we get? All right. Well, we have here, if we substitute 0.9 to here, we get 1 over 0.1, which is 1 over 110. Or you can use your calculator at this point. But this is negative because it's 0.9 minus 1. So this is negative 10. This one, if you try to substitute, you're going to get a negative 100. This one, negative 1,000, negative 10,000. And what is the pattern that we see? As we go closer and closer to 1, so we're going closer and closer to 1, this seems to become larger and larger, but in the negative side. So what's happening here is this is approaching negative infinity. Okay. If we increase the number of 9s, hence becoming closer to 1, we see that this function value right here becomes larger and larger and larger to the negative side. So we say, hence, we say that the left-hand limit is negative infinity. Okay? Or that the limit as x approaches 1 from the left of 1 over x minus 1 is negative infinity. Okay? Right. Now, if we do the same thing for the right-hand limit, well, that's not a hardship again. So x, f of x. Again, we are substituting numbers that are close to 1. We're substituting numbers that are close to 1. And this time, instead of to the left, this is now to the right of 1. Right? Now, of course, it will look like this. So say 1.1, and then we go closer by being 1.01, 1.001, 1.0001, etc., etc. And we're going to find out that the function values are just positive 10, positive 100, positive 1000, positive 10,000. And we see the pattern that this x gets closer and closer. 1. Wait, this is 1 from the left and 1 from the right. Okay. And we see that the function value goes positive infinity, right? Because this is becoming larger and larger and larger, but it's positive. Hence we say, hence we say that the right-hand limit is positive infinity. Okay. Therefore, the limit as x approaches 1 from the left of 1 over x minus 1 is positive infinity. Okay. Therefore, the one from the left is negative infinity. The one from the right is positive infinity. They're not the same. So the conclusion is the two-sided limit as x approaches 1 of 1 over x minus 1. The conclusion is it does not exist. Okay. All right. So this is a tabular method to solve things, and actually you can use this when you are out of options, especially in the contest, but try not to anyway. All right. Now notice that I have been careful in saying that the limit as x approaches 1 from the left of 1 x minus 1 is negative infinity. Notice that I'm not writing, and it's not the limit as x approaches 1 from the left of 1 over x minus 1 equals negative infinity. Okay? These two are, this is not correct. Okay? Strictly speaking, one, if the result of a limit is negative infinity or positive infinity, then it does not exist. Okay? So what is this for? Two, the infinities there describes the behavior of the limit. Okay, whether it increases without bound or decreases without bound. So if it's positive infinity, it increases without bound. If it's negative infinity, it decreases without bound. Okay, I need to be very, very careful about that. Y'all need to be very, very careful about that anyway. Okay, so don't write it as an equal sign. Strictly speaking, it does not exist. The limit does not exist. What we're doing here is we're just describing the behavior. If it's increasing or decreasing without bound. Okay, and another thing is third, infinity is not a number. Infinity is not a number. It is a concept of something that is immeasurably large. Okay? So, just as a note on syntax, write this and not this. This is correct. This is okay. This is not okay. Okay? All right. Now, what if we look at this function right here? What if we look at 1 over x minus 1 quantity squared? Okay? And we find its limit as x approaches 1 in general. Okay? Of course, that means that we're going to find the limit as x approaches 1 from the left, x approaches 1 from the right, and of course, the two-sided limit. All right, so as for best practice, when you're asked to find this limit right here, when you're asked to find this limit right here, you need to find this limit and this limit before. Okay. Now, uh, if we're gonna do the graph, if we're gonna do the table of values, right? Right. There's an x here. There's an f of x here. X here, f of x here. Okay. So let's focus on this one first. So again, this is for the first one. This is for the second one. All right. So numbers close to 1 that are to the left of 1, what are examples? So 0.9, 0.99, 0.999, 0.9999. Okay. And what do we get? 100, I think. Then you add two zeros every time, and it's always positive because it's squared. Oh, 1, 2, 3, 4, 5, 6, 7, 8. Okay, etc. So the trend is if it's 1 from the left, this tends to positive infinity. Similarly, if we do 1 from the right, so say 1.1, 1.01, 1.001, 1.0001, we get the same answer. Say 100, 10,000, 1 million, and I think this is 100 million. And of course, 1 from the left, and this is positive infinity. Now, we see that in both cases, the limit is approaching positive infinity. Okay? We say that the limit as x approaches 1 from the left of 1 over x minus 1 squared is equal to, is infinity, and the limit as x approaches 1 from the right of this function right here is infinity as well. The conclusion, since they both agree that it's positive infinity, the conclusion is the limit as x approaches 1 of x minus 1 squared, 1 over x minus 1 squared. Notice that there's no, this is now the two-sided limit, two-sided. The limit would be equal to, is infinity. Okay. Now, is there a way for us to solve this problem without a table of values? The answer is yes, of course. Of course. Let's do that. We look at the function 1 over x minus 1 squared. Okay. So this is now the solution without table of values. Okay. Now, it's 1 over x minus 1 quantity squared. So we are now wondering uh, what is the limit as x approaches. So the questions are the limit as x approaches 1 from the left, limit as x approaches 1 from the right, and of course the two-sided limit itself. But you can conclude this after you solve this. All right. So in here, you ask, what are the factors involved in the expression? In this case, you have 1 and x minus 1 quantity squared, right? At this point, if you see a 1 here, and if you try to substitute, you're going to get an infinity. So you look at where the limit is going to, and you try to substitute that, and you get infinity. At this point, you are deciding on whether it's positive infinity or negative infinity. You are now deciding on the sign. You're not deciding anymore if it's infinity because you have deemed that it is. Because if you try to substitute 1 here, okay, to the function itself, you're gonna get an undefined. So you're now thinking, hey, am I getting am I gonna get a positive infinity or negative infinity? How are you gonna know? So, all right. So you equate the denominator to 0. Okay. So I guess step 1, what numbers will make the denominator number or numbers? 0. In this case, it's x equals 1. Right? Now, step 2 is you now draw a number line with those numbers. Okay? In this case, what we're gonna have is just a number line with one number in here, which is 1. Okay? So technically, everything to the left of 1 is 1 from the left, and everything to the right of 1 is 1 from the right. Okay. Now, step 3, crucial. Step 3. Step 3, at any side, at both sides, determine the sign of the function. How are you going to do this? What you can do is you can substitute a number in this side and a number at this side. And at this point, you don't care about how close it is to 1. For hell, you can substitute in here to the left. Why not substitute 0? Okay. Now, if you substitute 0 in this function right here, well, you're going to get 1 over 0 minus 1 squared. You're going to get a positive number. Right? So that means that the limit as x approaches 1 to the left would be positive infinity. On the other hand, now to the right of 1, let's say 2. If you try to substitute 2 here, you get a positive number. So this one is positive as well. So this means that the limit as x approaches 1 from the right would be positive infinity. Again, what you're deciding at step 3, what is the sign at that part of the interval, that would be whether it's positive, that will decide whether it's positive or negative. Okay? So this solution right here doesn't need tables. Okay? This is the more correct solution than this. Okay? But as a caveat, for step 1, you need to make sure step, I guess 1.B, make sure that it only makes the denominator 0. Okay? It only makes the denominator 0. Meaning, if at step 1, the number that you get will make both the numerator and the denominator 0, that is nothing. You disregard that. Okay? Right. Let's try it in a simple function. Let's try it for this one right here. We want to find the limit as x approaches 5 from the left of x over x minus 5, 5 from the right of x over x minus 5, and of course, x approaches 5 two-sided. Okay? Now, what you can do is, right, step 1, 2, and 3. Step 1, what will make the denominator 0? So the answer is x minus 5, so equate this to 0, it's x equals 5. Step 2 is, of course, the number line. Okay? Right. So anything to the left, right? Anything to the left of 5 is 5 to the left. Anything to the right is 5 to the right. Okay. Now, step 3. Step 3 is we substitute some values. So for example, we substitute, let's say 4 in the left. In this case, if we substitute 4 to this function right here, what do we get? 4 over negative 1. So we get the negative number. So at this side, it's negative. The sign here is negative. Therefore, so how do you write that? Is negative infinity, since if x approaches 5 from the left, we notice that x minus 5 is negative. If x approaches 5 from the left, then x minus 5 is negative. You can also recall that another way to read this is x approaches 5 from the negative side. Okay? Now, 5 from the right this time. So you can substitute, say, 6. In which case, what do you get? Well, that's not on hardship. You substitute 6 here, you get 6 over 1. So that's a positive number. Therefore, from 5 to the right, so this is positive number as well. So this is positive infinity, since if x approaches 5 from the left, as from the right, x minus 5 is positive. So x minus 5 is negative here, x minus 5 is positive. And finally, the conclusion is, since that the limit from the left and the limit from the right are not the same, the conclusion does not exist, since uh, the left hand the left hand limit and right hand limit do not agree. Okay. Notice that for this entire thing, we didn't even need the table. All right. So that's it. Let's try this one right here. All right. Notice that there's something a bit different. There's something in the numerator. Right. Now, uh, we're gonna do the same steps. So, step one, what makes the denominator 0? The answer is x is equal to 6, because if you can just equate this to 0. Okay. Step two, when you draw the line that you need. So this is 6 from the right and 6 from the left. Okay. Oh no. Anyway. Then step 3 is you substitute values to the left of 6 and to the right of 6. So you substitute, say, 5 right here, and you substitute 7 right here. Okay. Now, if you substitute 5, what do you get? The denominator will be 5 minus 6 quantity squared, so it's positive. Again, you don't care about the values. You care about the sign. Okay. But the numerator is 4 minus 5 times 5, so that's negative 21. So that's a negative number. So this right here is negative. Similarly, 6 from the right. So if you substitute 7 right here, if you substitute 7 to the denominator, you get 7 minus 6. So quantity squared, so it's positive. But the numerator is 4 minus 5 times 7. So that's negative 31. So this is negative as well. So the conclusion is this limit right here is negative infinity, since if x approaches 6 from the left, you're going to write what makes it negative. It's either the numerator or the denominator. Okay? In this case, what makes it negative is the numerator. Since if x approaches 6 from the left, 4 minus 5x is negative. Similarly, for to the right, this is also negative infinity, since if x approaches 6 from the right this time, 4 minus 5x is negative as well. Okay, so they both agree the double-sided limit is called positive is negative infinity. Since the left hand limit and right hand limit agree. Okay, so that's it. I guess the hard part here is determining whether or not it's positive or negative. So that's the step three of our three steps. So you just gotta try to. So in step three, so you found the number, right? So you sub it to the function, but not only do you substitute it to the function, you also gotta be careful of what makes it negative or positive. Is it the numerator? Is it the denominator? Because you're gonna need it for the solution, right? So that is limits at infinity. Okay. However, just for a completeness sake, in step one, the number that we found is has a special name. It is called. Remember step one, we're finding what the number sorry what makes the denominator zero. Yeah, we're doing that. This number right here, what number? This number right here is called the vertical asymptote. Okay, so what is a vertical asymptote? A number x equals a is a vertical asymptote if the limit, if the left hand limit at a or the right hand limit at a is positive infinity or negative infinity. Okay, a number x equals a is a vertical asymptote if the limit as x approaches a or x approaches a from the left or from the right is positive infinity or negative infinity. This means that for this particular item, we say we say that in step one right here, x equals 6 is a vertical asymptote. Okay. Also, for this item right here, step one, x equals 5. Therefore, we say that x equals 5 is a vertical asymptote. Right? So that's it. That's video number one, that which is limits at infinity. The next video is infinite limits, which is there's a little bit of nuance there, but I think you'll do. So you'll be okay. So just as a reminder, uh, there's a quiz for this, which is gonna be uh part of the secret component. Just two items, just so I know that you did it during the day. Okay, that's it, and hopefully you are well.